Welcome to a lesson on the general form of a linear equation. So far, we've been working with the slope-intercept form of a linear equation, which is the form y equals mx plus b. And this form is very convenient because we could easily identify the slope, which is the coefficient of x, as well as the vertical intercept, which is equal to b. The general form of a linear equation, sometimes referred to as the standard form, is the form given here where we have ax plus by equals c. Notice how for general form, the x and y terms are on the left and the constant is on the right. Unfortunately, when a linear equation is in this form, the values of a, b, and c often don't tell us much about the graph of the linear equation. When we have a linear equation in this form, a, b, and c are constants, but integers whenever possible, which means decimals and fractions should be avoided for the values of a, b, and c. The only common factor among a, b, and c is 1, and a should be positive. But for both equations, we can still view x as the input and y as the output. Just remember, a vertical line is the only line that's not a function. Let's look at an example. Here we're asked to consider the linear equation 3x minus 5y equals 30, which is the linear equation in general form. In part A, we're asked to write this equation in slope-intercept form, or the form y equals mx plus b, which means we want to solve this equation for y. So beginning with 3x minus 5y equals 30, we first want to isolate the y term, so we'd subtract 3x on both sides and simplify. So here we have negative 5y equals, now on the right side, we could write 30 minus 3x, but remember in slope-intercept form, we normally have the x term first and the constant second. So let's write this difference as negative 3x plus 30. And now for the last step, to solve this equation for y, we would divide both sides by negative 5. Now on the right side here, instead of dividing the quantity by negative 5, let's divide each term by negative 5, which is equivalent. And now we simplify. So here we have 1y or y equals, notice here the coefficient is negative 3 divided by negative 5, which simplifies to positive 3/5. So we have 3/5 x. And here we have plus 30 divided by negative 5, which is negative 6, so we have minus 6. So this would be the equation in slope-intercept form, though this also could be given as y equals negative 6 plus 3/5 x. But this form here would be much more common. For part B, we're asked to identify the slope. Well, now that we have the equation in slope-intercept form, remember the slope is equal to m, which is the coefficient of x. And therefore the slope of this line is 3/5. Part C, we're asked to determine the vertical intercept, and we can do this two ways. We know the linear equation in slope-intercept form is y equals 3/5 x minus 6. So in this form, notice how b is equal to negative 6, and therefore the vertical intercept would be the ordered pair 0, negative 6. Remember, whenever given the vertical and horizontal intercepts, we should always give the point as an ordered pair. We can also find the vertical intercept using the general form of the linear equation, where in order to determine the vertical intercept, we set x equal to 0 and solve for y, and whenever determining the horizontal intercept, we set y equal to 0 and solve for x. So let's show how to find the vertical intercept using the general form. So starting with 3x minus 5y equals 30, we would substitute 0 for x, so we'd have 3 times 0 minus 5y equals 30. Well, 3 times 0 is 0, so we have negative 5y equals 30. Dividing both sides by negative 5, notice how we have y equals negative 6. And therefore the vertical intercept, as we already know, would have coordinates 0, negative 6. It is important to not give the vertical intercept as just y equals negative 6, because remember, this is actually an equation of a horizontal line. And now for part D, we're asked to determine the horizontal intercept, and there are no shortcuts when determining the horizontal intercept. Again, we must set y equal to 0 and solve for x. And we could use either form of the equation. Let's go ahead and use the general form. So we'd have 3x minus 5y equals 30. And now we substitute 0 for y. Notice how if we substitute 0 for y, this term is going to be 0. Let's just go ahead and show that. So we'd have 3x minus 5 times 0 equals 30. Simplifying, we have 3x equals 30. Dividing both sides by 3, notice how we have x equals 3 divided by 3 equals 10. So again, the ordered pair for the horizontal intercept would be 10, comma 0. So notice how to determine the horizontal and vertical intercepts using the general form of the equation was a fairly straightforward process because either the x term simplified out or the y term simplified out. And therefore, if we just wanted to graph the linear equation 3x minus 5y equals 30, we could just find the vertical and horizontal intercepts, plot those 2 points, and graph the line. I do want to go back to the part where we found the slope, though. Now that we have 2 points on our line, we could use our slope formula to also determine the slope. So let's also show that. Again, here we found the slope after we put the equation in slope-intercept form. But if we didn't do this, we could have found the vertical and horizontal intercepts and used the ordered pair 0, negative 6 and the ordered pair 10, 0 to find the slope using our slope formula, where we know the slope m is equal to y sub 2 minus y sub 1 divided by the quantity x sub 2 minus x sub 1. So if we call this ordered pair x sub 1 y sub 1 and this ordered pair x sub 2 y sub 2, we would have the quantity 0 minus negative 6 divided by the quantity 10 minus 0. This simplifies to 6/10, which equals 3/5. So if we didn't want to put the equation in slope-intercept form to find the slope, again, we could have found the intercepts and then used these 2 ordered pairs to determine the slope using our slope formula. I think we'll stop here for this part. In part 2, we'll focus on graphing a linear equation given in standard form. I hope you found this helpful.